All right, 5.B.3 notes, we're going to look at another formula for compounding interest. But before we do that, let's do these warm-up problems. So you have the option of investing in one of two accounts. The first account guarantees you will get 5% interest compounded monthly, and the second account, your monthly will be compounded quarterly, and you'll earn 4.5%. What should you invest in? So you generally want to invest in the one that has a higher interest rate. So we're going to invest in the one with the 5% interest rate. Now, even though the other one is compounded more often, the higher interest rate is still better than compounding it more often. It is a better choice. Then number two, you buy a new computer for $1,500. The value Y in dollars of the computer decreases by 25% each year. Write an equation that represents the value of the computer. So A equals, our starting point is 1,500, and that's going to be 1. And because it's decreasing, it's minus 0.25, because 25% is 0.25 as a decimal, raised to the t power. What is value of the computer after 3 years? So now we're going to substitute in 3 for t. And that's going to tell us the value of the computer after 3 years. So 1,500 times 1 minus 0.25 raised to the third power. And we get $632.81. So that's how much the computer will be worth after 3 years. So it went down by over half. All right, so now that was just kind of warm up with what we've done the last few days. Now we're going to talk about the number e. So the number e is called the natural base, and as n approaches positive infinity of this expression, what that gets us is about 2.718, this repeating decimal. And that number is the number e. Just kind of like how pi is 3.14, e, we approximate that as 2.72. So e is just a number. It's not a variable. And we're going to be using that number later on in this lesson. So example 1, are the following functions examples of exponential growth or exponential decay, and how do you know? Okay, so again, this e is really 2.72. So this is really going to be 4 times 2.72 raised to the negative 3x power. So this is going to be growth because b is bigger than 1. This one, 0.4, that's smaller than 1. That's going to be decay because b is less than 1. Again, e is 2.72, so you could rewrite this as, and because this is bigger than 1, this is growth, because our b value is bigger than 1. And then the last one, again, e. Now, you don't always have to do this, rewrite e as 2.72. I'm just doing it so that you can see that your b value is, in fact, bigger than 1, so that means this is exponential growth because b is bigger than 1.
So going off of that, what if we compounded continuously? What compound continuous means that you're always or constantly having your interest compounded. And there's another formula for that, and it looks the same, except we have something called the letter E, or Euler's number. It's a button on your calculator, and we will be using that in these formulas. So when your interest is compounded continuously, you have this formula A equals P times E raised to the RT power. And just like with the previous formulas, A is your final amount, P is your principal or starting amount, starting value, your R value is your rate as a decimal, and T is your time. So if we look at our examples here, you deposit $3,000 in an account that pays 3% interest, annual interest, compounded continuously. That means you're going to use this PERT formula right here. How much money will you have after 10 years? So our P, our principal, is 3,000. Our interest rate is 3% or 0.03. Our time is 10 years. So we would plug in these values to the formula and we would get A equals 3,000 times E raised to the 0.03 times 10 power. So I'm going to show you where that button is on your calculator. So in your calculator, let's type 3,000. And if you look to the left of the number 4, you see the ln. It says ln. And then right above that, you see E raised to the x power in blue. So that means you got to press second in that button. So you see we have E raised to some power. Well, now we can type in 0.03 times 10. And we get $4,049.58. Okay. So that is your answer. So this is just another formula that you're going to be using. And I know it can be confusing. Say, well, how do I know if I use this PERT formula or the formula with the N in it? And you have to look for the word continuously. If it does not say compounded continuously, then we have to use the formulas that have our N value in it. Letter B, you deposit $4,800 in an account that pays 6.5% interest annually. All right, letter B says you deposit $4,800 in an account that pays 6.5% interest, annual interest compounded continuously. What is the balance after 3 years? So 6.5%, people mess this up a lot and will say, oh, that's 0.65. No, if I had you guys say 6%, I know you would say, oh, that's 0.06. This is just, another place further. This is 6.5%. So the decimal equivalency for this is 0.065. Time is 3 years. And this says compounded continuously. So we are going to use this formula right here. So I'm sorry, this should not be A, that should be P. So A is equal to 4,800 times E raised to the 0.065 times 3 power. So I'll type this in to the calculator again so you can see how it's done. 4,800, then second, and this ln button, which is to the left of the 4, and then 0.065 times 3. And we get $5,833.49. So A equals $5,833.49. Then our last example, you deposit some money in a bank account 8 years ago. The bank paid 4% annual interest, so A is R is 0.04, compounded continuously. So again, don't be fooled by annual interest. You have to look for the word compounded. This is compounded continuously. So that means we're going to be using the same formula. Today, you have $1,200 in the account. So P equals 1,200. How much money did you invest 8 years ago? So that means T is equal to -8. So A is equal to 1,200 times E raised to the 0.04 times -8. So type that into your calculator, and you should get $871.40. So that will be your answer. So I'm hoping that you're feeling more comfortable with these formulas. The hardest part is really dissecting these problems and saying, okay, what formula do I use in this problem, and what are the key words that we're looking out for? You know, in compounded continuously problems, we are looking for the word compounded continuously. If we don't see the word continuously, but just see compounded monthly, quarterly, yearly, semi-annually, that means we have to use the formula from the other day with the N in it. If we don't see the word compounded at all, and something just grows by 6.5%, but we don't see the word compounded, we use the traditional exponential growth formula or decay formula, the A equals P times 1 plus R to the T power. Now, if you don't see the word compounded, you would use that formula. So it will take practice reading these word problems and dissecting them and underlying information, and that will make setting them up easier. And then once they're set up, you just plug it into your calculator and give us that answer. So thank you for watching the video. Make sure to like it and subscribe.